Hi, I'm Adam Pritchard, Assistant Curator of Paleontology for the Virginia Museum of Natural History, and I'm back with another tale of ancient life, in which we again return to the seas, but this time, not the world of whales, but that of sharks. Sharks have been prowling the waterways of the Earth for over 400 million years. Their family has ancient roots that dates back that far, and they have an amazing and interesting history of being sea predators throughout that entire time. But their fossil record is a curious one. There aren't a lot of specimens that have the entire skeleton of a shark preserved, even though they're very common. Why would that be? Well, it's frankly because sharks don't have bones in their bodies. Their skeletons are made out of a hard, but not as hard tissue called cartilage. Quite a bit more flexible than bone, a lot less mineral content, and as a result, a lot less likely to preserve in the fossil record. So unfortunately, we don't have a lot of amazing shark fossils that preserve the entire animal, except for a few that are found in fossil deposits that happen to preserve softer tissues than bone. But we still know a lot about sharks in the fossil record. And that's because of one thing in their bodies: teeth! This is a little box with hundreds of shark teeth that were discovered at the Carmel Church Quarry, the site that the Virginia Museum of Natural History works north of Richmond, Virginia, near Ruther Glen. There are hundreds of shark teeth, and this isn't a sample of all of the shark teeth we've collected from the Carmel Church Quarry. Oh no. This box contains the teeth from a single pit. Basically, one tiny part of the excavation searching for pieces of an ancient whale recovered hundreds and hundreds of shark teeth. Because sharks shed their teeth throughout their entire lives, so they end up in the fossil record quite readily. And teeth are some of the hardest tissues that a vertebrate animal can produce, so they tend to fossilize really, really well. And there are dozens of pits at the Carmel Church Quarry that preserve all kinds of different shark teeth. So we have an amazing window into the kinds of sharks that we had in this ancient environment. And today, I'm going to go through a little bit of the anatomy of these shark teeth and show you just a few of the cool species that existed 14 million years ago off the coast of Virginia. A very distinctive shark tooth that we have at the Carmel Church Quarry is that of the snaggletooth shark, Hemipristis. These teeth have a very prominent serrated edge with very, very large serrations on one side and smaller serrations on the other. And the root of the tooth is also kind of zigzag shaped. The snaggletooth shark is an animal that's still around today. It's a relatively deep water animal that lives in the Indian and Pacific Ocean and reaches lengths of about 7 feet. The animals that we have in Carmel Church have teeth quite a bit bigger than those, so we're seeing an animal that's at least twice that size. One of my personal favorite sharks that we have at the Carmel Church Quarry has some of the strangest teeth you'll ever see. This is actually just a single tooth from the lower part of the jaw of an animal called Notorhynchus, a member of a group called the seven-gill sharks. Notorhynchus have these prominent cusps that run down the length of their teeth, decreasing subtly in size, and then an edge that has a little bit of serration alongside the largest cusp. And their teeth are also particularly wide and narrow. A very curious shape that allows this shark, which is related to a lot of modern-day deep water sharks and bottom feeders, to survive in its ancient environment. Although they're not particularly common at the Carmel Church Quarry, you always know if you have a Notorhynchus tooth. There's really nothing to be mistaken for this incredible shape. I'd wager the most common shark teeth we run across at the Carmel Church Quarry belong to this animal, Carcharias, relative to the modern-day sand tiger shark. If you go to a big aquarium like the National Aquarium in Baltimore, Maryland, and see a large, nasty-looking, slow-moving predatory shark, it's probably a sand tiger. These large, slow-moving predators are not really that dangerous to humans. They have really distinctive teeth that are very, very straight and narrow side to side, and they actually have a slight curvature if you turn them into this sort of side view. And some of their teeth actually have teeny tiny little cusps right along the main point of the crown. Sand tigers are large predators fishes, crustaceans make up most of their diet. They're not going to be chowing down on us, and probably not chowing down on the whales that existed alongside in the Carmel Church environment. Another shark with a modern relative that we have at the Carmel Church Quarry has teeth that look like this. This is a tiger shark tooth, belonging to the genus Galeocerdo. In tiger sharks, the tooth has a really sharply angled crown. Basically, the pointed end angles real sharply to give it almost sort of a parallelogram shape. And then one side has these big, prominent serrations. Tiger sharks are kind of known as the garbage cans of the sea. They're well known ecologically for eating pretty much anything that gets into their mouths, including human garbage. I've heard stories of people finding like tires inside of their bellies. Not an ideal meal, but proof that tiger sharks are pretty general in what they're willing to eat. But tiger sharks at the Carmel Church Quarry get a little confusing, because in addition to the true tiger shark, we have an animal called the false tiger shark. And this is one of its teeth, Physogaleus. In this animal, the tip of the tooth does angle, but not nearly as sharply as in the true tiger shark. And there's a small serrated edge underneath the main angled tip of the tooth, but it's not as prominent as what you see in the true tiger shark. Unfortunately, as far as we know, there are no modern-day relatives of Physogaleus still swimming in the ocean, so we're not sure how similar this animal was to a true tiger shark. But having similar teeth could suggest that these animals lived very similar lifestyles 14 million years ago. False tiger, true tiger. Took me a long time to be able to recognize the difference between these, and I still have trouble sometimes. But it's there. There's a lot of different sharks, some of which had very similar views. Oh, it looks like I've made shark glasses or something. It's perhaps the most famous fossil shark of them all. This is a tooth of a Megalodon shark. Carcarocles megalodon was the largest predatory shark we know of in the fossil record, and its teeth are notable not only for their exceptional size, it's probably the largest one we have from Carmel Church, but also for having a sort of band of dark tissue across the bottom of the crown of the tooth called a bourlette, very fine serrations along the side, and no real side cusps on the tooth. As a result, Megalodon teeth are pretty much unmistakable. Here's one that's still partially embedded in its original rock matrix. Now, the size of Megalodon the shark is still open to question because we don't have material other than teeth in most cases. Current studies based on statistical analyses and modern shark sizes suggest that Megalodon reached sizes of 60 feet or more. That's about the length of a tractor trailer. It was a big, big animal. And at Carmel Church, we have quite a few specimens that show us that this animal was a major player in the ecosystem there 14 million years ago. Our oceans are filled with an amazing variety of natural resources. From tiny microorganisms to the largest whales, there's an extraordinary amount to eat. And sharks have been predators of everything in that size range for a very, very long time. There's evidence that the giant Megalodon sharks indeed fed on the whales that lived at that time. Sand tiger sharks are good at eating fishes, crustaceans. A lot of the other ones I talked about are their modern relatives at least, are bottom feeders. And tiger sharks, like I said, eat just about anything. It's a habit we call generalist. Quite honestly, specific diets of a lot of sharks, especially those that live in deep water today, are really hard to assess in detail because it's hard to observe those animals for more than a short period of time. But it's the study of those modern vertebrate animals that gives us a sense of what is going on in these ancient sharks. So even though we don't have any skeletons of sharks from the Virginia fossil record that I'm aware of, we do have an amazing picture of sharks through time in Virginia. With the thousands of teeth recovered from the 14 million year old horizons of the Carmel Church Quarry, we can get a very decent idea of not only who the players were in the ecosystem, but also the relative abundance of those animals at the site. Who was here? And about how many of them were there? And we can compare those shark tooth discoveries from Carmel Church to other sites from the Atlantic coasts from about 50 million years ago right up to the modern day to see how the diversity of sharks has changed through time off the Atlantic coast of Virginia. My special thanks go out to paleontology technician Lucy Tretto, who several years ago developed a shark tooth identification guide specifically for our work at the Carmel Church Quarry. It's been a big help in my learning the diversity of these animals and how to identify their teeth. So if you're ever looking for fossils, keep an eye out for shark teeth, and then go on the internet and try and determine what they belong to. That could tell you a whole lot about the ancient environment that they lived in and their tale of ancient life.